Hello all. Welcome to my game development stream. I'll be streaming for about an hour and a half today. Not quite that, maybe an hour and 15 minutes. So where we left off the last time I was streaming, I had a little bit of like a sample game going, and I can kind of show what that looks like currently. So this might not be super visible, but you should be able to see I've got a gun that's in front of my character somewhere, and there's this little cube out here in the distance. And, well, I'm going to not show off too much of it right now because you can see things are very dark. That's because I was just working on adding lights back to the engine. My renderer had support for lights, but the engine was not, there was no way to create lights in the scene through the game engine. So I just added that ability, and now I need to update my example game to actually create some lights, otherwise everything's going to be very dark. So in my main function, I'm going to do let's see, let light equal directional light new. We're going to make it point, let's say, to the right and down and backwards. Forwards. I think that's the way I started looking. We're going to give it a strength of 0.25, and we're going to give it, I got 0.2, give it a color of white, just make it a white light. Let's see, gotta import lights into my scene. Let's just do that. I have to forget these because I don't have any way of creating static stuff. And now we should be able to run this, and we have, oopsie. We have bugs in our my lighting system. Ooh boy, that seems not right to me. I don't know about you. That seems super duper not right. And you know what? I bet I could tell you almost exactly what I'm doing wrong. So let's take a look at that shader. So, God, I'm so bad at navigating my own file system. Let's see. Go into my render, go into the built-in materials, and let's take a look at our flat lit shader, our untextured lit shader. Let's take a look at how I calculate stuff for the different types of lights. thing that I'm looking for is light offset. We are doing light position view. So my suspicion was that I was not using the light position in view space. Oh no, here it is, light direction. And this is what I'm messed up is I'm seeing how I'm. So what I'm doing here is when I calculate the point light, I suppose I should make this a little bit more visible. So right now I support 3 types of lights within my shader. The first one here is no light, in which case there's just ambient light, just to make things slightly visible, but I don't calculate diffuse light or specular light. Then there's a point light, in which case I calculate the direction of the light for this particular fragment. I calculate everything in view space, so you note I'm using light position view and the vertex's view position. And then for a directional light, I don't have to calculate the light direction because the light direction is given by the light itself. But note that I'm using light direction when I should be using light direction view to calculate L. And just to double check, I'm not doing anything else in screen space here either. So that should probably be enough to fix it. Hopefully that fixes it. Now everything has to recompile because I updated the renderer. And that seems super not right as well. Maybe better, but still not great. Man, what is going on? So it seems better because now we can see the you can kind of see the lights on the gun change as I move around. But the specular, I think it looks like this, or maybe not, maybe. Oh, you know what? I think I was noticing this earlier. I think my specular goes negative. I think I'm calculating my specular wrong. Because I've noticed, I can actually do, let's see, CD, cargo run, example, experiment. So let me see if I can pause this at a point where it's going to be visible. Okay, so this is a little example that I have in the engine. This is using a directional light with the same configuration that I was just using within the game. So it's kind of, I believe it's kind of pointing into screen and down and to the right. So this front left upper portion should be lit, and then like the bottom right towards the back should be unlit. And you can see that's kind of what's going on here. This part is lit, and you can see that the part on the right is dark red. So it's red, but it's unlit. But then you can kind of see a space in between the diffuse part and the ambient part where it's black. And so I'm actually not 100% sure why that's happening. I said it just a second ago. That's probably the specular going negative. That's actually probably not right. That's probably the diffuse going negative, because this whole portion up here I would expect to be the specular, all the stuff that's lit up full red. So maybe something's going negative around the edges, or the specular is wrong, because you'll notice we don't really have a proper specular highlight. So I'm actually going to go all the way into my renderer, and I'm going to see if I can reproduce this within the renderer and see if I can fix it there. So I'm going to start with example no light. All right, so that is my unlit example. Looks cool. Let's take a look at what a point light does. Point light looks cool, right? Seems completely reasonable. We've got a specular highlight. We've got the model is diffuse lit. It's actually being lit with a purple light, strangely enough. It's not that I've got the material set up to be purple, it's actually that the light is purple, and I might want to change that. Actually, I think that let me double check, because that might not be true. So let's go to my point light example. Let's see. Yeah, I make the surface color of the mesh white. I make the light color purple. Let me swap that around, because that seems not really representative of what most common use cases would be. There we go. So now the mesh is purple, the light is white. You can see we've got a specular highlight, we've got nice soft diffuse shading. This looks right to me. Let's see what my directional light looks like. This is my directional light example. This also looks fairly correct. Let me tweak that example as well. So again, let's make the surface color purple. Let's make the light color white, since that reflects closer what I'm doing in the engine. Very strange. So let's see. In my game currently, the surface color is white. Let's see, let's also new GPU mesh material. Let's see, how would I just use the default material? See if I can remember how to do this, because I don't even remember how to use my own engine. Render.default material, that's how I get my default material. So let's get rid of this, since we probably don't care about that. Let's do, when I create my mesh instance, render.default material. Let's take a look. So now this should pretty closely match what I've got going on in my game. Actually, even in that little example scene in the engine, I'm using the same mesh that we saw before. I'm using a directional light with, I believe, the same configuration. So we should be seeing that same weird visual artifact that I was getting, but I'm not seeing it. So I'm going to say let's move the mesh a bit. Mesh anchor ID. Let's say let's move it, let's keep it centered horizontally. Let's move it down one, let's move it back one, or into screen one. That would be -Z. Let's see if we can reproduce those visual artifacts. Let's move back a few more. Right, I did get that. Okay. Okay, so this is weird because this looks great right here, but if I close this out and I go cd ... and I do cargo run example experiment, this doesn't look great. This looks very not great. And I've got to wonder, why does this look so different than the one in the example? So let's compare them a little bit and see exactly what's going on. So let's close down stuff that is game related. Alright. Diffuse light is our default material. So in my experiment example, the one that exhibits the issue, we create a directional light with a white color and 0.25 strength. In the directional light example, our light has white color, 0.25 strength, direction 1, -1, -1, direction 1, -1, -1. Let's see, we create a mesh render, we don't set any of the... Oh, you know what, I'll bet you like $7 this is what it is. I bet my specular values aren't set up properly. Alright, so let me show you my little hack that I've got in the engine to handle the fact that I have no way of creating materials. So let's go up into my engine code. I believe it is in the actual engine source file. It would be when we create mesh instances. So I create a mesh instance, and I create it with the default material, and then immediately I set a bunch of properties within the mesh instance. Now this covers kind of two hold on a sec. Alright, so this covers a couple of issues. So what's happening here is I create a mesh instance, and the mesh instance, as the renderer provides it, is something that ties mesh data to a material as well as an anchor within the scene. So a mesh instance is what allows the renderer to render a mesh in the scene with whatever given physical properties it has. Mesh instances have properties which can be used to change the color of something, or like basically from the CPU specify what the shader is doing in the graphics card. I don't right now support in my material system default values. So if we take a look at this material, I have a bunch of properties. I've got like surface shininess, surface color, surface specular. I would really love to be able to, you know, give this a default value of 4, give this something like make this give those default values. My material parsing system does not support that currently. Although it wouldn't be too terrible to add. I'm not going to do it now, but what I will do is, let's pull this over here. I'll add a note in my, like a to-do in here. Let's see. Diffuse flat, the default material. Oh, hey, look, I did that. So I can delete that note. I like that, I like that. So let's do add or let's see, add or yeah, add default values for material properties. Actually, I want this to be a an issue, but I'm not going to waste time typing up an issue on the stream. So yeah, so I suspect that's the problem. Is surface shininess in particular specifies how large the specular is, and if that's set to 0, it's just going to, I think, cause garbage to come out. So if yeah, that looks much better, doesn't it? Yeah, that explains that. So now if I go all the way up to my game and I just do cargo run, stuff should actually look like not garbage. Yeah. Hey, look at that. That actually looks like something. All right, so. Ooh, what is going on? Do I have specular? There we go, I do have specular. Look at how smooth that specular is. I don't know if I ever streamed this back before I fixed up the renderer, but back before I fixed up the renderer, I didn't have gamma correction turned on in my engine, and so like the specular highlight on stuff would just look like complete garbage. Like the shading looked terrible, and I couldn't understand what was going wrong. Like I thought I had done something wrong in my shader code, but it was, as I understood it, just the simplest Phong lighting. And then later I realized it didn't have gamma correction turned on, and once I turned it on, everything looked great. So that's kind of what you see now. But so now I can continue showing off what's working in the game right now. So I've got this gun, and I can click as much as I want, but it's not going to shoot. That's because I got to load some bullets into it. So if I hit R, it loads a bullet. If I scroll the mouse wheel, it rotates my cylinder. So right mouse click pulls the hammer, left mouse click shoots, and now this cartridge is empty, so I can't shoot anymore. but I can press R to load a bunch of bullets into my makeshift revolver. If I hit right trigger to pull the hammer, I can then click and it'll shoot. I can try to shoot all the ones that haven't been shot yet. And yep, now I've fired all of my bullets. And my gun is now empty. So there's a couple of things in here that you'll notice. One, the cylinder, the quote-unquote cylinder for the revolver is not properly centered with the actual gun itself. That is because I'm pretty sure the gun mesh itself. Let's see if I can. There we go. This gun mesh right here is actually not centered. Like, I'm pretty sure the like center point for the mesh is right around here, and so the cylinder thinks it's centered over the gun, but it's not because the gun mesh is all messed up. I made this gun mesh, which would explain why it's kind of wrong, because I have no idea what I'm doing. I'm actually going through and learning how to use Blender right now, so that I can make a new gun mesh, one that's actually a revolver, and two that is centered properly and isn't terrible. I'm going to want to, kind of one of the next things I want to do is I want to be able to animate it properly and make it look not terrible. But that is getting proper art assets, or anything even remotely close to proper art assets, is going to take a long time. So in the meantime, I'm going to want to do some other stuff. Like, when I fire a round, I'm going to want some visual change on this shell casing that's in the, or this cartridge that's in the revolver. I think I want to kind of like visually shrink it so it looks like it's just an empty shell cartridge without the bullet in it. I want to add a hammer to the gun so you can see whether the hammer's back or not. You've got to add it I've got to add a way to empty all the cartridges from the cylinder so you can load new ones in. Another thing I want to do that's more for debug purposes than actual like gameplay purposes, I want to get this little model gun that's here in the scene to basically do exactly what the player's gun is doing, so that I can kind of like, from a third-person perspective, look at the gun, visually verify that it does all the right things. Because, from the first-person perspective, you don't really have a good view of what the gun is doing. So I want to fix that. And then that'll take me a solid eternity to do, so once that's done, I'll kind of figure out what the next step is. So, yeah. Oh, one thing. I did make a slight fix. To my diffuse lit renderer. So I quickly would like to also fix my textured renderer, because eventually that is what I'm going to be using all over the place once I have textures. There's this right here. Instead of light direction, it should be light direction view. Should also fix up this. And point light. Directional light. I add those same comments here. Yeah, so on the note of things within the material system that need to be updated, you can see that I've got if I want to keep these two materials in sync, the one on the left here is a not textured but lit shader. The one on the right is a textured lit shader. And to keep these two are almost exactly the same, the only difference being that the textured one also samples from a texture to get the surface color, whereas the one on the left just uses a specified surface color. But otherwise they're exactly the same. But the code has to be repeated between the two because I have no mechanism for sharing code between materials. That's something I just haven't even really thought about. I probably won't put much thought into for a good long while. Basically, until I start doing any kind of heavy work in shaders, I'm just not going to pay much attention to that material system. Eventually, I want that to be a really nice material system, but I also don't really know what a really nice material system even is at this point. So let's see. What do I want to work on next? I'm thinking an easy thing to do would be to visually show cartridges that have already been fired in the gun. So I would go to, I believe it's gun.rs. I can take a look at cartridge. It has a transform. But more importantly, if I do fire, here we go. So if some cartridge, if not cartridge has fired. To do it, change the cartridge mesh to empty the cartridge. And what we're going to do for now, just as like a kind of hack, since I don't have any proper meshes, cartridge.transform.set scale. We're going to do how about this? Let mute scale equals cartridge.transform.scale. We're going to do, can I do this? Scale.set z 0.001. Scale. Will that compile? Did I actually add the set z helper method? And by the way, this is taking a long time to compile because whenever I change the default material in the renderer, that's actually built into, I can show you, polygon lib or polygon source source GL mod. So the default shader is actually baked into the binary using include bytes. So anytime I change this material, it has to recompile the renderer, which is, on the one hand, very annoying and inconvenient, but include bytes works really nicely because now I don't have to try to figure out where this is at runtime. I can just always have a default material, and I don't have to have any kind of special handling within the renderer to be like, oh, you tried to create something, but there's no material available, so it's not going to work. So yeah, let's see what happens now when I fire a cartridge. So you kind of, you can't really see it, but I can kind of rotate to the bottom. How do I get a good view of that? Okay, yeah, there we go. So if you look at the bottom, you can see that this is like a non-empty cartridge and it's still pretty full. And this one is an empty cartridge and it looks kind of flat. It's just, it's not as long as the other ones. So if I unpause this, yeah. Yeah, so now you can see there's only one unspent cartridge, and now it's empty. And it's kind of hard to tell that it's empty. However, I feel like that's kind of what I want. Yeah. Yeah, because from the back, it's not necessarily easy to tell if a cartridge has been fired or not, or if, yeah, a cartridge has been fired or not. I think in a real gun, maybe you'd be able to tell by looking at if you can see where the hammer struck the cartridge or not. But I think with a revolver, I can let's look up some pictures of revolvers. See how visible it is, because I'm gonna kind of get to decide what the revolver looks like for game purposes anyway. But let's see what a real revolver looks like. Most importantly, can you see what the cartridges look like when the revolver's in its normal position? And it looks like in this kind of revolver, you'd be able to see the back, but they're also So it looks like the answer is sometimes you can see the sides of the cartridges. So you wouldn't even be able to see what cartridge is in the top position anyway. So I'm gonna deem that one not terribly important. It's just a little bit nice to be able to see what's happened. The next thing I want to do is mechanically, when you pull the hammer, I would also like it to rotate the cylinder. So let's do if not self dot is cocked. So when you pull back the hammer, I want it to also rotate the cylinder once, because that is how a revolver works, I think, sometimes. What that'll allow you to do is, so I'm going to rotate, I'm going to add 6 bullets, and now I'm going to pull the hammer, fire, pull the hammer, fire, pull the hammer, fire, pull the hammer, fire, pull, fire, pull, fire. Yeah, so now you can just do right click, left click repeatedly to shoot the gun and empty all the cartridges, which is that's the mechanic that I want. So after that, I either want a visualization of the hammer so you can see whether it's back or not. I want a way to empty all the cartridges and load new ones in. I need to implement animations, because you'll notice when I run the game, when I move when I say rotate the cylinder, it moves at discrete intervals. There is no smooth animation on that. So I want animation on that. I'm going to want the same thing on the hammer when the hammer comes back. I'm going to want to animate the cartridges as you add them into the gun, as you drop them out. So I suppose what I could do is I could start building up a checklist over here. Let's do maybe this. Do I want to do this as documentation, or let's do this? We're going to do so let's see. On my to-do list so far, we have add visualization of hammer. We've got I want to animate cylinder rotating, animate hammer pulling back, shit, what did I say? I like just a second ago listed off a bunch of things I wanted to do. So we got hammer, cylinder. Let's take a look at the game. Rotating the cylinder. I want to add let's see, I want to add empty cartridges. Add a way to empty cartridges. And that should cover me for now. So I guess we can just kind of go down the list. The order isn't overly important, so start by adding a dumb old visualization of the hammer. I'll go to my revolver, so we got transform, mesh body, rigid body. I'm gonna do pub hammer transform pub hammer renderer mesh renderer and hammer mesh is going to be ref mesh. Let hammer transformer transform. We're going to make this equal transform new. We're going to do let hammer renderer equal mesh renderer new. We're going to give it the hammer mesh. We're going to give it the hammer transform. And then we're going to set the position to be let's do this. Transform.set position. Let's see. We're going to set it to start pose plus we're going to do vector 3 new. We're going to put this at 0.05 and 0.05 back. And we're going to hammer transform dot set scale. We're going to make this and let's call it 0.0 0.05 wide, 0.0 0.01 tall and maybe This is deep, so 0.01 deep. Let's call it that. Now we got to get this compiling. So we need hammer transform. We're going to do hammer renderer. And now we need to also give it a mesh for the hammer. We're going to use cube mesh. Is this going to fail the bar checker? Awesome. Okay. Okay, so what does my hammer look like? Probably about right. Pretty reasonable for a hammer, I would say. We need it to now follow the gun properly. So, where was I? This one said gun. So we got cylinder offset. We need to do the same thing. We need a hammer offset vector 3. We also want hammer pivot vector 3. So hammer offset is vector 3 new we want to be this, and oh whoopsie, let's do this, and we want hammer pivot to be, I'm going to call this 0.0. Let's do minus 0.025 minus 0.025. Oopsie, not semicolon. And so I want to first off just update the so in here we're updating the cartridges every frame. Now I want to update the position of the hammer to follow the gun. So it's always going to be let hammer position equal self.transform.position plus self.hammer offset self.hammer transform dot set position hammer position so I should be able to see this is following the gun. However, it does seem to be this is weird. Yeah, so it's not orienting with the gun. So what we also want to do is self.hammer transform.set orientation self.transform.orientation. Now it should also be oriented with the gun as well. and it is, so we can see that it's oriented with the gun, but it's slightly wrong because of that offset. So this hammer offset isn't being updated correctly. Self.transform.orientation times self.hammer offset. So we want to rotate that offset based on the orientation of the gun as well. So now that should always be in the right position. So now I want to, well, I've added a visualization of the hammer, so that checks that box. Yay. Actually animating that hammer pulling back is going to be slightly more of a nightmare. But animating the cylinder rotating seems like a little bit less of a nightmare. So let's take a look at how my cylinder is being handled. So rotate cylinder. So I haven't done any kind of fixed animation. So the only animation you're seeing here in the engine, the only movement you're seeing is either completely player driven, like the forward motion, which is the forward motion or looking around. Movement is handled by the keyboard, looking around is handled by the mouse. So that's entirely driven by player input. Or the gun's movement, say when I fire a bullet, let's see, the gun has that kickback. So you can see it each time I fire the gun. That is physics driven. I'm doing a spring simulation, which, so I'm not doing any kind of like manual tweening over a period of time. I just apply a force to the gun and the simulation does all the motion. So this rotating the cylinder is going to be my first attempt at tweening. I'm going to be doing I'm going to have to do some kind of tween to get the cylinder to rotate every frame, either at a fixed speed or probably maybe some easing. So I think I'm just going to start with kind of the dumbest implementation I could think of. So we're going to do let's do cylinder time. It's just going to be an F32. We're going to have a constant value for the amount of time it takes the cylinder to rotate. We're going to do so we need to keep track of the current time value of the tween. We need to know its start value and end value. And we need to know, well, hold on, let me think about this for a sec. How do I want to do my cylinder rotation? So there are actually two ways the cylinder can be rotated. One is the player scrolls the mouse wheel, which manually rotates it, in which case it's going to rotate at discrete intervals, and so that's where we're going to want to do the tween. So we're going to want to tween from one position to the other so it doesn't just jump. The other way that the cylinder can rotate is while the player is pulling back the hammer, we want the cylinder to rotate in sync with that, as kind of as if there's a mechanism in there where as you pull back the hammer, there's also like some gears or pulleys in there that causes the hammer to rotate, or causes the cylinder to rotate with it. If the player is on a controller, I could imagine a situation where, you know, the left trigger of the controller is mapped to the hammer, and if you pull the left trigger halfway, the hammer will come back halfway, and that should also only rotate the cylinder halfway. And so maybe if you let go of it there, the hammer will go back to its resting position, but maybe the cylinder won't go back, because I know that mechanism, that's kind of how that mechanism works in certain cases. But while I'm working on PC and I don't have controller support, pulling back the hammer is always going to be a discrete action, just like scrolling the mouse wheel. So I think it's safe to do tweening all the time. In the case where the player pulls back the hammer, I still want the cylinder rotation to be in sync with the hammer coming back. So I'll just have to do some extra work there to make those two things are synchronized. So what I want to do is cylinder, I'm going to call this cylinder tween. It's optional, and it's going to be, let's call this struct cylinder tween. We're going to do time F32, target time F32. We're going to do start pose so how do I want to represent my start and end positions? Because if I do it as U size, I do have the issue of if we're rotating from the fifth cylinder to the first cylinder, I worry that it's going to be too easy to mess that up and accidentally rotate everything backwards. So maybe what I want to do is maybe do something like I want to do the start pose, capacity, and direction as an F32, perhaps? So let's do this. Let's do it this way. Cylinder tween. So this, yeah, of course. Let's derive, debug, clone, and copy on this. Oh, Jesus Christ. So instead of cylinder time, we now have cylinder tween is none at first. And then when we update our transforms, we're going to want to update our cylinder tween. So if let some tween equals self dot cylinder tween dot asmute, Oh boy. Okay. So we'll want to step the time forward each frame. So step the time, divide to get our t value. So let's do tween dot time plus equals time delta f32. Let t equal tween dot time out of tween dot target time. What we can do is if tween dot time greater than tween dot target time to end the tween, else. So we want to calculate the start position. So how do we currently calculate the position of the cartridge? So I calculate the rotation as tau divided by capacity times position. Position is the index minus the position modulo the capacity. So really what I'm calculating with this tween is there's going to be a slight, there's just going to be an offset value added to rotation. So, and that's really the only thing I need to calculate. I don't even care about I care about direction, so I'll leave that in there, but you know, I probably don't even care about capacity. What I can do is, this can be a value from 0 to 1, let's say. And that's just going to be time out of target time times direction, right? So we want tween time out of target time times direction. Oh, busy pants. So at the end of the animation, so here's what we're going to do. Else. So let tween offset equals this. We're going to use the magic of expression-oriented programming. We're going to get rotation plus tau out of capacity. So I think what we want is is that 32. I think this is what we want. Pose plus tween offset. Because position is going to be some integer value. It's going to be 0, 1, 2, 3, 4, or 5 for a 6-cylinder revolver. And then tween offset is going to be a value between -1 and 1. And we want to add that to the position and then apply that. And then that gets scaled by the capacity. So that represents, it's going to be -1 to 1 of that little slice between two cylinders. Oh, there we go. Tween dot direction. So the thing here is, at the end of the tween is done. We want to set the cylinder's position. Set the cylinder's position to the end position. Actually, yeah. So let's do it like this. Cylinder tween. So we actually, instead of start pose, we want end pose as a use size. And then we'll just do self.cylinder.position equals tween.end pose. And then somehow in here I have to do self.cylinder tween equals none. But I'm guessing that's not going to compile because of the borrow checker. All right, borrow checker, what do you want from me? How should I tell Rust sometimes I'm going to overwrite this cylinder tween and sometimes I'm not? So if tween offset, let tween offset equal if let sum tween equal self.cylinder tween as mute. That is some pretty non-intuitive junk if you're not familiar with Rust. So let's see. Update tween time. What would be the easiest way of doing this? I could so the borrow occurs here. So what if I did it like this? So here's what I would do. Dot cylinder tween sum tween. Well, cylinder tween equals none. Okay. So that's a bit annoying. I feel like I want a better pattern for that. So what was happening was when I was doing self.cylinder tween.as mute, I was mutably borrowing this option tween. I was mutably borrowing this whole thing so I could get a mutable reference to the contained tween object and modify it. But depending on the data inside this object, I might want to change the value of the entire option to none. And so Rust is saying like, hey, if you do that, you're going to invalidate the reference you have to that internal data, which, you know, it's completely right about that. I would have broken things. Well, actually no, because I never try to read from that data after setting it. So I think once Rust gains non-lexical lifetimes, then that would have compiled and that would have been fine. So that's a little bit annoying. That's a bit of the borrow checker being too coarse-grained to fully understand what I was trying to do. But I do think that's something that will be fixed eventually. But to be so what my solution was is I basically copy the data out of the tween and then override the entire option afterwards. So let's see. Now that that's set up, I should be able to do rotate cylinder, and now instead of updating the position directly, self.cylinder position as I size plus rotation modulo capacity as I size as you size. That is a mouthful. Okay, so we want to do let's do this. If let sum tween equals self dot cylinder tween, else. And so what I'm doing here is if there's not a tween in progress, we do this self dot cylinder tween equals sum cylinder tween time 0.0 target time, let's make it half a second. End pose is going to be this junk. And then direction is going to be rotation as either 1 or -1. So I'm going to do rotation as F32 divided by rotation as F32 dot abs, right? So we're gonna do that, and then this gets a to do. What should we do when the cylinder is already rotating? I think for now I'm gonna just not do anything if the cylinder is already rotating, and we'll figure out from there. Well, let's see that. So let's see what this looks like. Uh-oh. Look at that. Ah! That looks like a bug to me. Let's see if I can figure this one out. Oh, because you know what? Is tween offset 0 a bunch? Let's take a look. Let's see what's going on. Print line tween offset. So let's find out what is going on there. It's Nan. Okay, terrific, amazing. I hate that. What is going on? So this should be none, right? So if let sum mute tween equals self.cylinder tween, self.cylinder tween should be none right out the gate. Right? Right? What the heck is going on? Why is this not none? Because I can imagine this is nan because tween dot target time is 0, but it should be none, so I shouldn't even be having that problem. Oh, direction is nan. Oh no! No! I'm being bit by my own foolishness. So you'll notice here that every frame I call rotate cylinder with input mouse scroll, except mouse scroll is 0 most of the time, so that's going to make it crap its paths. So if input mouse scroll not equals 0, I thought I was being clever by just doing it every frame. Turns out I'm not clever. Okay. So now if I do that, it would appear to me that my my bullet is rotating in the wrong direction. So let's turn off these and ask myself, why is my direction backwards? So I could just be really simple about this and say minus tween offset instead of plus tween offset. Look at that. Beautiful. Beautiful. And the only change I think I'll make is no, I think I'm cool with that. I think I'll just make this go a little bit faster. But other than that, I think I'm satisfied with that. I think I don't want it to be a linear tween. I want it to be a probably an ease out. But this should be fun. Now let me try shooting all my cartridges. Excuse me. Isn't that great? That almost feels like a revolver. Okay, well, I think that's where I'm going to call it quits for today. Thanks for coming out and watching. Yeah, thanks for watching. I'll be sure to do this again sometime soon. I'm enjoying being able to actually work on a game and not just on the engine. This is very satisfying. Alright, well, I will see you next time. Thanks for watching.